Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at an example from section 4.9 homework. This is question 25. It says, given the following acceleration function of an object moving along a line, find the position function with the given initial velocity and position. All right, so this is one where we have to work backwards from what we're used to doing. So we start with our known here, and that's that the acceleration function a of t, and that's going to be equal to negative 38. So before, when we started with the position function and we moved from that to the velocity function, that to the acceleration function, we took the derivative each way. Since this time we're starting with the acceleration function and we're moving back towards the position function, we're going to be using the antiderivative. So we're going to need to know the power rule for the antiderivative here, and then we can do this and use these other equations here to help us find our constants of integration. So starting here, if we just take the antiderivative of this, that's going to be the velocity function is going to equal, so the antiderivative of negative 38 would just be negative 38t. Kind of do that off to the side here, but think of negative 38 t to the 0, right? That's just another way of writing negative 38. And then if we apply the antiderivative rule, that means we add 1 to the exponent, and then we divide by that new value, by the 1. So that's going to equal to negative 38 t to the 1 all over 1, which is just equal to negative 38t. So that's where we get that negative 38t. So negative 38t plus some constant of integration. So we have to assume that there may be some constant there that when we took the derivative, that zeroed out there. So that's why we have a little placeholder for it. But we're given some information here that's going to allow us to solve for that constant of integration. So we're given that v evaluated at 0 is equal to 25. So I'm going to replace v evaluated at 0 with 25. And that's going to equal to negative 38, and replace the t with the 0 plus c. And that's going to give us that c is equal to 25. So our constant of integration for the velocity function is in fact 25. So now I can go back and rewrite my velocity function. V of t is equal to negative 38t plus 25, plus 25. Now we're ready to take the antiderivative of this, which will give us the position function. So s of t is equal to, and we're going to apply the same rules we did before. So that's going to be negative 38. This is t to the first, so that becomes t squared when we add the 1 to the exponent. And then we have to divide by that new value, which is 2. Plus, and then we're going to do the same thing with this constant as we did up there, and that's just going to become 25t. And then we also need to add a constant of integration, and since it very well may be different than our last one, I'm going to use a different variable, so we'll say plus d. You can use any variable you'd like. So let's clean this up a little bit. So s of t is going to be equal to, that's going to be negative 19 t squared plus 25t plus d. All right, but again, they give us some information here. They say that the position function s evaluated at 0 is equal to 0. So I'm going to use that just like we did before. So s of 0 is going to give us 0 is equal to negative 19, and we put in a 0 for t squared plus 25 times 0 plus d. And these two terms will cancel out, and I'm just going to get d is equal to 0. So I can finally write my full position function here as negative 19 t squared plus 25t and plus 0. So I'll just leave it like this. And this is the final answer here. All right. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.